Hello, everyone. My name is Zach with HP Additive Manufacturing Solutions, and welcome to session 2 of HP's Beyond the Layers, a Polymers 3D printing series. Here, you'll build a solid understanding of HP's Multi-Jet Fusion 3D printing platform and how our polymer solution fits into real-world production. Each quick 30-minute session focuses on a core topic to help you get up to speed and ready to work with HP's 3D printing technology. To recap session 1, we explained the printing process and talked about 3 companies that turned to HP to enhance their manufacturing capabilities. Hanger Clinic is printing orthotics that are customized to their patients' needs, making them more comfortable to wear. Blazing Rods is redefining automotive parts with additive manufacturing and saw how the HP 3D printers can not only help them reiterate designs quicker, but also create end-use parts for their custom cars. And finally, we saw the Eye Above project, who are working in Africa to monitor the wildlife population, identify animal traps, and control illegal poaching activities using cutting-edge drones. They turned to 3D printing with HP to optimize their drone design, lightweight their final product, and streamline the printing process to meet the demands of this amazing initiative. Now, to continue the series, we'll go beneath the surface of our printers with our next topic, the components powering HP's Jet Fusion 3D printing, presented by Application Engineer Steven Corsick. As a reminder, we have the Q&A option at the bottom, so submit your questions and we'll try to answer them at the end or get back to you via email. Now, I'm going to hand it over to Steven to get us started. Go ahead, Steven.
Awesome. Thanks, Zach. Like Zach said, today's session 2, Beneath the Surface, where we're going to discuss the components that power the Jet Fusion 3D printing process. So our agenda today is to talk about the essential components that are needed for any installation, as well as some of the production optimizing components that we offer. At the end, we're going to review that end-to-end workflow again that Katone showed in the first series and discuss what each step does with each component. And then hopefully at the end, we'll have some time again for some Q&A. So getting right into it, let's start with the first section, the essential components. The essential components typically consist of the processing station, the printer, and the build unit. And here we're going to go into each component individually and discuss what they do and what gives them an advantage. So the first device we're going to talk about is the build unit. This is a multi-function chamber that serves 2 purposes. It moves mixed powder and printed parts between the printer and the process station. In the powder management side of things, this build unit contains a load of ready-to-print powder that is the exact precise amount of powder needed to print the next job. That powder is stored underneath the build plate, and as the printing process continues, it's moved from under the build plate over to the top of the build plate where it is actually printed. Inside this build unit, we have thermal containment. There's heaters, and it's controlling all of that build temperature during the printing and the cooling process to give us the part integrity that we need. This is also an advantage because it supports continuous printing. We're able to remove the build from the printer to allow that mandatory cooling period to happen outside of the printer. That allows us to place another build unit inside the printer and get the printer running again to maintain uptime as best we possibly can. As we see in this little image below to the side, we can see that that ready-to-print powder is being moved from the bottom over to the top as it's being printed during the printing process. The next piece of equipment we're going to discuss is the process station. In this piece of equipment, all of the powder handling is managed. As you can see in the video, the build unit is placed inside this device and is loaded with recycled and mixed material that is ready for printing. This device also manages the unpacking of parts in most systems. This has an integrated vacuum and a backdraft system, which enables easy and clean unpacking of printed parts. It also has intelligent material tracking, which monitors powder usage, refresh rates, and gives you batch traceability. The processing station can also enable a fast cooling function. This accelerates the part cooling time post-print while still inside the build unit, which reduces the overall cycle time, giving you a faster time to part. In the video over to the right, you can see that they did use an optional piece of equipment called a natural cooling unit, which we'll discuss in the next section. But you can see that there is a vacuum that was able to vacuum out all of that excess powder, and that backdraft was able to keep all of that excess powder inside the system, preventing any from escaping the entire workflow. And then lastly, but not least, we have the printer itself. So inside the printer is that multi-jet process that Catone had mentioned in the past. We load that build unit that has the full mixed ratioed powder contained inside the build unit. And then that process of pulling the powder from under the build plate and placed on top of the build plate happens. And then the agent is deposited on top. It's that multi-agent process that we've discussed in the past using fusing and detailing agent to perform the printing process, which gives us those fine details and those isotropic part properties. The printer also has advanced part quality monitoring. It's got integrated thermal systems that enable those layer by layer defect detections, and it has an adaptive feedback loop. So it will make continuous adjustments during the printing process to ensure you have the best quality. Print management is controlled via HP's Command Center, which is a server-based file deployment solution. So no need to walk around with the USB. You can send the print straight from your computer to the printer itself. The machine also has intelligent telemetry. It has continuous monitoring of system sensors, which enables prompt error detection in the case of a component failure. So these three devices, the process station and the build unit and the printer, make up the core components of what most installations look like as far as the basics required. You start with the build unit, you place it into the printer, you perform the printing process, you then move it back to the processing station where all of that excess powder is reclaimed, you refill the build unit, and then you can restart the process. The build unit offers you that ability to have multiple build units, giving you production flexibility and improving your printer uptime and overall machine utilization. Now we're going to talk about some of the production optimizing solutions offered by HP. These are solutions that are not required for usage to go from end to end in the process, but do enable a better uptime, a better yield, or a better throughput of the entire system itself. These are typically geared towards people that have multiple printers or a significant amount of production capacity that they're looking to achieve. The first is something we already saw in a previous video, which is called a natural cooling unit. This is a device that is compatible with the build unit and used in conjunction with the build unit. The natural cooling unit will be placed on top of the build unit after printing while the build is still hot. The build unit will then push the entire printed cake that it contains the excess powder and the printed jobs into the natural cooling unit, as you can see in the video. It takes about 5 minutes to go through this entire process. You're going to then place a guillotine back underneath and then use a forklift to place the natural cooling unit on a shelf off to the side. This allows the parts and the build to go through a passive part cooling. So now it's just using the room temperature to cool down to a natural state that it can be unpacked in. Crucially, this enables equipment flexibility. So now we can allow that job to cool off to the side. We can refill that build unit and put it back into production. It also gives you flexibility where if you're not quite ready to unpack something because it's not urgent, you can set it off to the side, get your build unit back into the system. And it's also a cost-effective throughput booster. The natural cooling unit is it's known by an RFID, but it's a relatively simple piece of equipment compared to the build unit, which has a significant amount of the printing process built into it. So as a way to cost effectively improve your throughput, you can use the natural cooling units. Another device that's optional is called the automated unpacker. This performs that vacuuming step that we saw in the previous video that takes place in the processing station inside this device instead. This reclaims that bulk powder from those parts and recycles it back into the powder recovery loop. It recaptures all of that reusable powder and puts it back into the material cycle, which then would be moved over to the processing station and reloaded into the next build unit once it's been mixed and ratioed. It's already pre-configured. It's designed to work with the natural cooling units because most that are using a that would be able to take advantage of a system like the automated unpacker are already using the natural cooling unit systems to optimize their production. It's also a very quick process. The default settings are about 30 minutes to go through a full unpacking, of which an operator does not need to be nearby. The machine will perform that bulk reclaim automatically. But a cool thing is you can configure your profiles. So you can allow the machine to run longer to ensure more clean parts, or you can allow it to run faster to perform less effective cleaning of the parts, but you'll be able to get your parts much quicker. So those configurable profiles allow you to tune your process to the parts that you're unpacking. You can use this for both high mix ratios. So you're like a service bureau and you have a lot of different designs and a lot of different style of parts that are going through, or you can have it can be used for something like this, which are dental arches, and you can really tune in the process parameters to be exactly what they need to be for the parts that you're running, if you're running the same job over and over and over again. All of these then again are tied back to that material management and back to that job management server. So you don't need to worry about what powder is where. The machine is going to keep track of it for you. Another device that we offer is called the automatic changeover device. This is a workflow automation that minimizes touch points during the print start and stop. This is an uptime optimizing device. This allows a second build to start immediately after completion of a first build. It's a relatively simple device. It allows the printer to eject a build unit, and then a pre-prepared build unit can push that first build unit off to the side and then pull that second prepared build unit into the printer itself. This is a dramatic improvement on printer uptime because say you have a 12-hour build that would finish overnight because you started it at noon the previous day. Now, when that job finishes at midnight and there's no one on site to start a second job, the automatic changeover device can start that job for you. All you have to do is have a second build unit filled with mixed and ratioed powder, as would happen in the processing station, and the second job queued up and ready to go on the printer. This allows you to have fleet orchestration, which coordinates equipment. You're able to use HP software to optimize your scheduling. So if you want a build to finish at a specific time, you can schedule it to finish at a specific time. And it allows you to add essentially a second shift of operations. There's no one on site to start a job. That printer is going to wait until there is someone on site to start a job. With this device, no one is needed to be in the building. It will do it automatically. Lastly, we have the powder management system. This is designed for mass production. It's a dramatically improved powder handling capacity system. It reduces the floor plan and reduces the reliance on labor when you're comparing it to the processing station. This replaces the processing station's operations, where instead of having the process station do that reclaim through a vacuum, now you're using the automated unpacker. You're also using a separate device to mix and reload build units in a much more efficient manner. It's automation ready. It's designed for integration with third-party automation and software. And because you're using material out of a bulk Gaylord, it's going to be able to give you the best material prices possible. This is a system that's intended for use with many multi-jet systems and those who are really looking to truly enable mass production using multi-jet fusion. It's quite the industrial system, and it has a very, very strong impact on your overall throughput and cost. So as I mentioned before, now let's review the entire end-to-end workflow again. We have the printer, the build unit, the processing station, and in this video, they use the natural cooling unit as an option. From there, they will take a loaded build unit that's already been prepared and place it inside the printer for the printing process. This is where that multi-jet, multi-agent process is going to take place. It will take about 12 hours for a full height build to go from startup to finish. And then after that printing process, the operator will come over and remove the build unit from the printer itself. They can then place another build unit inside the printer itself to immediately start a job right after, or they can wait until they have another build unit ready to go. From here, the operator is going to place the build unit into the processing station. As I mentioned, they're using the optional natural cooling unit device. That build, after it had gone through the cooling period, could be unpacked directly from the build unit. But in this case, they're going to have the cooling take place in the natural cooling unit. After they remove the slicing blade, they're going to connect the vacuum to the top of the natural cooling unit to ensure that no powder escapes. Oops, accidentally clicked. They're going to, like I said, place the natural cooling unit. They're going to remove the slicing blade. They're going to connect the vacuum to the top of the natural cooling unit to ensure no powder is able to escape and to control the powder during the ejection process. The natural cooling unit and the build unit have RFIDs on them to, again, understand what build is in what device. That build is then pushed from the bottom to the top into the natural cooling unit. And then after the slicing blade is reinserted and the vacuum is placed to the side, the operator will use a forklift that will then remove the build unit and place it over on a shelf to complete its cooling cycle. The cooling cycle depends material to material, but is typically about 24 hours. After that, the operator is going to use the vacuum to clean up any residual powder, and then they can refill the build unit. At this point, the build unit's connected to the processing station. The processing station is going to automatically mix and ratio that powder for you. You don't need to be exposed to any powder during that process. It will automatically pull it from HP's material management system and place it into the build unit. From there, the build unit's moved back over to the printer and the print is started again. If you have two build units, you could already have that printer running at that point. In this scenario, again, they're using the natural cooling unit, so they will manually unpack via the natural cooling unit. After that cooling process has taken place, they place the natural cooling unit back into the processing station. They place a cover over it just to ensure no powder escapes. They lower that hood and begin the unpacking process. All of that bulk material is reclaimed via the integrated vacuum system. The parts are placed off to the side, and then the entire inside of the natural cooling unit is cleaned. After that process is completed, the cover is removed, the natural cooling unit is placed back into its storage location, and then the parts are then moved over to the final step, which is media blasting, something I didn't cover today. Media blasting is the last step that's needed, and then you're ready to continue the printing process and start the entire thing over again. So that's the entire workflow. That is the printer, the build unit, the processing station, and the natural cooling unit. At this point, that is the end of what we're going to cover today. Next time, we're going to have a deep dive on the 5000 series portfolio in terms of machine model. So though there are most of the printers look the same from the outside, there are some key differences on the inside between the different models of the HP Jet Fusion 5000, 5200, and 5600. My colleague Justin Hopkins is going to review all of those differences and when it makes sense to evaluate one printer versus another, and when it makes sense to bring in some of those optional components from a production setting to truly ensure you have the best output for the capital equipment you have on hand. At this point, I'd like to open it up to the Q&A to see if there's any questions. Zach, do we have any questions?
Yeah, perfect. Thanks, Steven. So we do have a couple questions in. As a reminder, everybody, there is the Q&A option at the bottom, so just click into there, submit your questions, and we'll get as many as we can answered. Steven, first question, can you explain the difference again between a natural cooling unit and a build unit, and then what the benefit of one over the other is?
Fantastic. I would love to. So a build unit is required for printing. The build unit contains that powder management system. and it is where the printing process actually takes place. The natural cooling unit being placed on top of the build unit is essentially an ancillary device that allows you to bring the build unit back into production ready state. So there's a mandatory cooling time for the materials after the printing process. It's very warm inside the printer. You need to allow it to cool to a safe temperature before unpacking. And the build unit, you could allow it to cool off inside the build unit just fine if you wanted to. But to ensure you have the best uptime of your equipment, you also could push that full printed build into the natural cooling unit and then place that natural cooling unit off to the side to allow it to print, or sorry, allow it to cool on its own. So the natural cooling unit's a much cheaper device relative to the build unit. So from a capital utilization perspective, it makes a lot more sense to take advantage of the natural cooling systems. Hopefully that
Uh,
answers your.
yeah, yeah, I believe it did. So with a build unit, a natural cooling unit, you're basically freeing up that build unit to start a next build and continue printing that way, while your first build is, as the name suggests, naturally cooling on a shelf somewhere, right?
Exactly.
Yeah, so it keeps your production uptime up. Okay. Kind of along the lines of the build unit, can you explain again one more time where the powder is housed in the build unit? So it's at the bottom of the build unit, filled up in the processing station, correct?
For sure. Let me jump back to that first slide, the build unit itself. So I think this is one of the things that is least talked about in the printing process really is where is the powder actually stored. So in that video that we had seen earlier, this little disc is removed and then the powder filling attachment from the processing station is connected. So the powder is actually stored underneath this silver plate. This silver plate moves up and down during the printing and unpacking process. So as you can see in this little animation here, the printed powder is stored underneath this. And then during the printing process, it's moved from under that build plate over onto the top. And that's where the print heads come across and they lay that multi-agent process down to actually print the parts. And as we have the build plate going down, we've got space being freed up underneath that build plate because the powder is being moved from the bottom up to the top during the printing process. So it avoids you needing to fill the printer with powder. It comes automatically from the processing station and it keeps things really nice and clean and tidy. We don't have to worry about manually handling a jug of powder or a keg of powder or something like that. It's all contained inside the build unit. So there's no need to have a scale or a mixing device or chamber or anything like that. It's all managed by the processing station and by the build unit itself. So powder is stored underneath the build plate, and then that build plate during the printing process goes down, and then after it's cooled, or either before it's cooled, you can push it up to the natural cooling unit to then refill that under plate space, or you can allow it to cool inside the build unit itself and unpack directly from there.
Nice. Yeah, thank you for that. Okay. Now let
For
me see
sure.
what other questions we have here. Uh, okay, one thing that came in. So you mentioned at the end media blasting of the parts. Can you just touch on that really quick and what you meant?
Yeah, for sure. For sure. So if we see, let's go back to right here. So we see in this process, after the unpacking process, the parts have a little bit of powder that's still stuck on the surface here. You can see that. Uh, Most consumers will use a glass bead media blaster to do that final cleaning process. So there's always going to be a little bit of material stuck to the surface. The vacuum can't quite get everything off of it. And so a glass bead sandblaster basically will take care of that, any remaining residual powder that's on the surface. This is not something that's provided by HP, but typical channel partners will quote one if you don't already have one that you can use. Another piece of equipment that I didn't mention is actually an explosion-proof vacuum. So just in case you have any powder on the floor or you're looking to do just general cleanup or cleanup of the printer in between print processes, that would be another thing that would be quoted by your channel partner, and they would make sure that you have the proper ancillary equipment during the startup process. But a media blaster takes care of this little bit of residual powder that's right on the surface here and cleans it up and makes it a nice homogeneous colored part.
Nice, thank you. Looks like we got some great Q&As coming in. Do you
Right.
have a specific software to prepare the build, or do you have a partner for this, or how does that work?
That's a fantastic question. I think we're actually going to cover that in a future Beyond the Layers webinar of the different offerings that are out there. So HP does have a solution called 3D Build Manager from HP, and it works just great. It's free. It's included with the system. It allows you to orient the parts and send them from the computer to the printer itself, and you can select all of your print parameters and things like that. However, there are others that offer integrated solutions that work directly with our systems. Off the top of my head, I know there's Materialize Magics has a plugin for HP software, and then so does Fusion by Autodesk, which has a plugin for HP's solution. So actually, if you order a multi-jet system, it comes with a free year of Autodesk Fusion. So it's a pretty cool partnership we have with them. So I think we're going to go in a deep dive in a future Beyond the Layers episode, just because there's a lot of different offerings out there, and it can be kind of tough to pick which one is right for you because a lot of them have different benefits, one over the other. It's not a one size fits all solution. That's a great question.
Yeah, yeah, and kind of along the same lines as that. The question, does that software have an automatic tool to accommodate the parts in the most efficient way?
So it's not directly integrated into that tool, but a new upcoming solution from HP is called the Build Optimizer, which will do exactly that. That solution will be cloud-based through our web portal, which is called PrintOS. Again, something we'll go deep in on the future episode. But that will take your parts and orient them optimally for best quality, best cost, or best time to part. So yes, there is an optimization solution. It's not quite released yet, but it's coming very, very soon.
Nice, thank you. And then, are there any current or in development methods of accelerating cooling?
Yes. So one of the things that we can do inside the processing station, if I go a little bit to here. So this vacuum that he's using to clean off all of these parts, Uh, unfortunately, we don't have a video of it, but one of the things that you can do is called fast cooling. So you can place the build unit into the processing station with the lid still on the build unit. There's a lid, there's a cover that comes with the build unit that allows you to cover up the powder. And you can place that vacuum onto that lid and enable the fast cooling process. So the fast cooling process uses that vacuum to draw fresh air through that build to accelerate the cooling process. So you can dramatically reduce the cooling time by using that process. It does occupy the processing station while you're doing it, but if your ultimate goal is, I need this part right now, it is a way to dramatically reduce the amount of cooling time that would normally take place inside the build unit naturally or inside the natural cooling unit off to the side. So yes, there is a process called fast cooling.
Nice, thanks, Stephen. So, uh, it looks like we're at the 30 minutes. So if anybody submitted any additional questions, we'll get back to you via email shortly. I want to thank you, Stephen, for presenting today, and thank everyone for attending this session of HP's Beyond the Layers. Keep in mind, you'll be receiving an email with today's replay and the registration link for session three's topic, More Than Prototyping, From First Success to Full Production, where we will discuss how our solution scales to your company's needs. I hope everyone has a great rest of your day, and we look forward to seeing you in the next session. Thanks, everyone.
Thank you.